Questions 23 and 24 both involve some calculations, so I'll do spoilers and then talk you through the answers. So in here it looks as if I've got some flasks, I've got some moles, I've got some masses, but this is the key thing. It says the temperature and the pressure are the same. So I need to use PV equals nRT because that's got temperature and pressure in it. And actually when I look, the pressure and the volume are staying the same because it's a seal flask, same volume, same pressure, same temperature, and R is the gas constant, 8.31. So everything is staying the same. So flask A contains this number of moles of methane. So PV equals nRT if I work it out for this one, and all of these are going to stay the same. When I work out n number of moles, it equals that. When I work out this, n number of moles with the same pressure, the same volume, the same R and the same T, n must be the same for this as well. So if PV and R and T are the same in this one and the same in this one, then this other number, n, must be the same in both of them. So in other words, all this information is saying that flask A and flask B have got the same number of moles of gas. So 4.0 times 10 to the minus 3 moles of methane, this flask B must contain 4.0 times 10 to the minus 3 moles of methane as well, because n number of moles must be the same for both of them, because everything else is the same. So when you work out n, it must be the same. So flask B has got 4 times 10 to the minus 3 or 0.004 moles of gas as well. We've been given a mass in milligrams. To turn a small unit, a milligram, into a large unit like a gram, then we divide by 1,000. So 340 milligrams is 0.34 grams. Moles is mass divided by mR. So moles, which is 0.04, we've established that, 0.004 rather, equals number of mass, 0.34 divided by mR. It's prompting us from the mass and the number of moles to work out mR. mR is 0.34 divided by 0.04. The mR is 85. In other words, it's saying which of these chemicals has got an mR of 85. Well, let's go through them. A, CH2Cl2. A carbon is a 12, hydrogen's a 1, Cl's a 35.5. You add it and you've got 85. You could check the others, but I've found it straight away. It's answer A. Analysis of sample of a chemical C22H33N5O4S showed that it contained 0.0195 moles of carbon. So what do these numbers tell you? They're the ratios of the number of atoms or the number of moles. It's the ratio of number of moles. So if I had 22 moles of carbon, I'd have 5 moles of nitrogen in there. So I've got less moles of nitrogen than I have of carbon. 22 carbon for every 5 nitrogen. So to work out the number of moles of nitrogen, I could multiply 0.195 by 5 and divide by 22. If you can't see that, another way of looking at it is that the ratio of moles of carbon to nitrogen is 22 to 6, so it's a 6, not a 5. I divide both by 22, so the ratio of carbon 1 to nitrogen 6 divided by 22 is 1 carbon for every 0.273 moles of nitrogen. So my moles of carbon is 0.195 multiplied by 0.273, 0.0053 moles of nitrogen. So I have got 0.0053 moles of nitrogen. If your maths is good, the quicker way of doing that would have been, as I say, to say 22 carbon for every 6 moles of nitrogen, a lot less nitrogen than carbon. What's the fraction of nitrogen compared to carbon? 6 divided by 22 multiplied by the 0.195, and it gives you 0.0053. Any way that you can work that out. Now then, I've got the number of moles of nitrogen in there. What's it asking me? What mass? Well, I know moles is mass divided by mR. Moles, I've got 0.0053. Mass, mR of nitrogen I know is a 14 from the periodic table. 0.0053 is mass divided by 14, so the mass is 0.0053 times 14, 0.074. So my answer is C.